This week on Developer Voices, we're talking about a new programming language and some new ideas for how programming languages should work by looking at the language Unison. Now, Unison's been built specifically to tackle the problems of distributed computing. And that might seem a bit niche, but it's much more general than that. Because from a certain point of view, when you think about it, pretty much all computing is distributed these days. We don't run code on one machine anymore. There's the obvious kind of distributed computing when you push your code out to a cluster of servers and they're all working together on the same task. But even in the more humdrum settings, I write some code on my laptop, I share it with the team, they share it back with me, we put it out to a CI server and to test and prod. And even though they're running different instances in different environments, isn't that all distributed code across a distributed code base? From a certain point of view, I think it is. And that's the cool thing about Unison. It's got some ideas for how we can unify all those different kinds of distributed code and make the experience better, whether it's just you working on your laptop with a friend or a mega cluster. With one simple trick, as they say in the clickbait. I'm not going to give the game away, but I'll give you a hint. You know how Git has changed the way we share source code? And it did it with an immutable append-only database that was cheap and easy to copy, and just enough cryptography to verify that database as we pass it around and be absolutely sure that if I've got the same hash as you, then we're working on the same source tree. I've always thought Git was a really smart approach. It's worked really well in practice, and yet we only apply it to source code. Can we take that idea further? Well, let's find out. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Rúnar Bjarnason. I'm joined today by Rúnar Bjarnason. Rúnar, how are you doing?
Doing great. How are you?
I'm very well. You're coming to us live from Boston, right?
That's right. I'm just outside of Boston.
But from Icelandic roots?
Yeah, I'm originally from Akureyri, Iceland, but I've come a long way since then.
You really have, and you've got a career to match a long journey. I think it's from what I gather.
It's been a long, strange trip.
Yeah. Do you have an academic background for starters?
I do not. I went to a technical college in Reykjavik, but I dropped out because I got a job cataloging computer viruses.
And yet somehow the academic stuff has caught you up in a way.
Yeah, I've always been a reader, always been sort of an autodidact. Taught myself how to program, and on the Sinclair Spectrum ZX.
Oh, which one did you have?
Back in the day, I had the ZX48K, the ZX Plus.
The ZX Plus. A neighbor of mine had that, and I have never been more envious of a human being before or since. And I eventually got the next version, the Plus 2. But that's going back too far into history. We need to get a bit more up to date more quickly.
Okay.
So, to ground this, you in 2014, you released a book which you co-authored called Functional Programming in Scala.
That's right.
And you clearly had got the functional programming in a statically typed language bug, but that hadn't gone far enough. So what did you do next?
What did I do next? Well, I started with my co-author Paul. Started developing the Unison language. So Paul had actually been developing Unison after, we sort of parted ways after the book, and so he started to develop Unison. And I was doing Haskell programming for various clients, and working in industry. And then he got a little bit along with this Unison language, and asked me to join and form a company. And so we founded a company called Unison Computing, and we're developing this language.
And that's been going for nearly 10 years now?
The language?
The language and the company?
So we started the company in 2018.
Oh, okay.
And I think Paul started working on it maybe 2016, something like that.
Okay.
But the sort of genesis of it is that we were actually working together. So when we started writing the book, we were working together writing Scala, purely functional Scala. And we actually developed a small language for for our employer at the time. And so we got the sort of language development bug from there.
Yeah. Hang on. Why is a client asking you to write a language from scratch?
So this was for doing financial reports and sort of doing quantitative analysis on portfolios and stuff like that. And so it needed to be very expressive. And they had this sort of visual language where you could assemble sort of blocks of code together, and kind of evolved into a whole language. It was pretty cool.
But you didn't get the visual programming language bug. You went back to text, right?
Oh, yeah.
Yeah.
I think visual programming is kind of a dead end in that it doesn't really allow for programs that are as expressive.
No, and it doesn't manage complexity that well, I think.
No, that's true. It doesn't hide the complexity very well.
No, and it makes it a rat's nest to debug. Anyway, but you have some other ideas about how programming should work. And I often think you can categorize languages as what they're like that's gone before and what's brand new about them that we should pay attention to.
Yeah,
so,
sort of genus and differentia.
Yeah. Can you categorize Unison that way?
Sure. Unison is a statically typed, purely functional language, similar to Haskell in that sense. But it is also a sort of image-based language, similar to Smalltalk. That is, the code base is not a collection of mutable text files. It's an actual database that has your code in it. So that's rather similar to what languages like Smalltalk do.
Okay.
So that's how it's similar to other languages. But the way it's different is that the code, so all the code in your code base is referenced by hash. So that's really the main differentiator. So every definition has a unique, mostly unique and sort of eternal address, which is the hash of its implementation. And so you can unambiguously refer to any expression or type using its hash.
So you're doing this trick that Git does, but they do it like hash a file and store it under the hash. You're doing it hash a function definition.
Yes. So we hash a function definition, we hash types, we also hash namespaces, that are collections of hashes.
Right. Why? What does that get you?
Yeah, why? So the main, for me, the main benefit of this is that, it allows you to unambiguously communicate code over time and space, basically. So over space, meaning that you can communicate over the network. You can unambiguously communicate code over the network. So whereas if you're developing a distributed system in a traditional language, you have to do something at network boundaries. For instance, you'll take your data structures, you'll serialize them to XML or JSON or some custom format, and then send it to the other machine. And then on the other side, you have to have some code that deserializes that and turns it into whatever data structures you have. Or you can do remote procedure calls, but then the locations will have to agree on what the code is beforehand, and they can't get out of sync and stuff like that. But in Unison, we can send the hash over the network and say, hey, here's the code I want to run, that I want you to run. It has this hash. And if it has the hash, then it just goes and runs it. But if it doesn't have the hash, then we actually serialize the code. We capture the continuation of the program and we serialize that along with all of its dependencies up to some agreed upon depth. And then the remote location continues to execute the program.
Does that include the state of the computation?
It does.
So I can get halfway through a function, suspend it, and ship it over the network and have it run elsewhere?
Yes.
That kind of... Okay, so that remote code execution raises a lot of questions. The first one is security.
Right. So for one thing, you wouldn't want to, accept this kind of call from the internet, right?
Yeah.
So you wouldn't want to expose your Unison node to the internet and say like, oh, hey, send me whatever code you want. So that's the first thing. And the second thing is that since Unison is strongly and statically typed, and we have effect types, so Unison calls these things abilities, and so different locations have different abilities. And when you expose a location or like a Unison node to like the rest of your cloud, then you specify what abilities it has. And so you can't, for instance, send a computation that does some I/O, for instance, unless the location specifies in its type that it is allowed to perform I/O.
So I could build a service that allows you to send me code and I run it, provided that code is only either pure functions or gets and sets on your personal key value database.
Yes, for example.
And it can't do anything security dangerous outside of that.
Right.
That's interesting.
Yeah.
Because I remember because I saw you give a talk about Unison at ERDEV a few years back, which is a great conference in Sweden. And you said something which relates to this. You said, languages have not caught up with the internet age. Which is a good quote related here, and I want you to unpack it.
So, well, that was a few years ago, but I think what I meant by that was that languages mostly talk about what one CPU process is doing. So one OS process. It might have multiple threads and like doing lots of different things at the same time, but it's mainly there's a single OS thread and it's doing some stuff. And if you want other OS threads or other machines to do stuff, you now need to break out of your programming language. There usually aren't any facilities in the languages for talking about what other machines or other OS processes are doing. And so you need to, get out protobufs or, some other non-programming language in order to bridge that gap.
I can think of at least one attempt to do that, to build a language from the ground up that doesn't believe it's running on one node, and that would probably be Erlang.
Yeah.
How is your solution to this problem different?
Well, how is it different from Erlang? So I don't know enough about Erlang in order to talk about it intelligently, but I believe that the main difference is that we have this notion of hashing, is that we can unambiguously talk about code, like over the network. So I think that if you are sending a message to an Erlang location or node, like you need to know something about what code it's executing. Like there's going to be some kind of like version mismatch, or there's some impedance mismatch there that I believe they probably can't bridge without this kind of unambiguous addressing.
because your system is going to be able to say, if I start this running on one node, it can branch itself out to other nodes because it can deploy itself, right? It can say to another machine, run this, and by the way, if you need it, I can send it to you.
Yes.
And I can imagine the program just spreading out in its own self-managed rolling upgrade.
Yeah, that's right.
That's pretty cool.
And it's all done, purely in the language. So there's an ability called remote, and it gives you this ability to send a computation. You basically have this notion of an abstract location, and there's a function called, I believe it's called fork at, and it takes like a lazy computation, so like a captured continuation and a location, and it'll send the code to that location.
And it's sending the data too, right?
Yeah, it's sending the whole closure.
Right.
So everything that the computation depends on as well.
Okay. So it could not only map reduce data over a cluster, it could map reduce the map reduce computation as well.
Yeah.
I mean, it could. Yeah, I have an image of a benevolent virus in my head spreading itself across the cluster.
Benevolent virus is a good way of describing it. We're calling it just-in-time deployment, but yeah, benevolent virus is a cool way of saying it.
Depends on whether we want to sound safe or dramatic, I guess.
Right.
Yeah.
It's a lot like just-in-time compilation, where, translating the program to machine code to run fast happens sort of just in time. And, in Unison, translating to network calls happens just in time.
Okay. This raises a couple of things. Let's go for the first one. It must raise the question, are you planning some like global Unison cluster where I just ship my code to that?
Yes, that's in fact Unison Computing's flagship product is Unison Cloud, where we basically provide you with a library that you just put in your code base, and then you have an API key, and when you call this library, you are basically deploying your computation on our managed infrastructure, and you can source as much computational power as you require.
That feels like it's bridging the gap or eliminating the gap between something like you can get an EC2 machine on AWS, or you can get a Lambda, which is running a single function.
Right. It is like that, but I think it's, for one, it's a lot simpler, and for another thing, you're doing it in your language. So it's really that you write your code, and then to run the program is to deploy it. Right? It deploys itself on the managed infrastructure. You don't have to write, YAML files or like some kind of configuration. You don't have to hire, armies of DevOps people to like manage your clusters and manage your EC2 instances and stuff like that. So, the Unison Cloud is doing all of that for you, and all you have to do is just run your program, and that deploys it.
So I've got a hint of this from a talk I saw you give, but you would you literally you load your code into like a REPL and run it, and it works, and so then you say run it at Boston Compute .unison.
Yeah, basically.
Right.
So there's a local interpreter for the remote ability. So you can write your program as a distributed thing, using the remote ability, and you can run it locally using this sort of local interpreter. And there are other interpreters where you can like diagram your system, so you can like see how it's like distributing itself over the network. And that's all done locally. But then there's the Unison Cloud interpreter, which goes and actually deploys it on managed infrastructure in the cloud, and it's live.
So how does that deal with I guess these are related things, but the other thing you need, as well as deploying code for a remote managed service like that, is you need persistence of data and you need migration of data.
Yes.
How are you dealing with those things?
So that's early days so far.
Mm-hmm.
So right now, the things that you can do, for instance, is you can talk to S3, for instance, right now.
Okay.
And Unison, Unison Cloud is, close to like wherever your S3 instances might be, or your S3 objects might be. But we're also developing a managed storage system. So it's a typed storage. It's basically just a Unison library, and then you can take any Unison object and you can persist it in the cloud, and then you get basically typed access to it back. And there are often there are problems with these kinds of things where like I can persist any object and then serialize it back. But if you try to do this with I don't know, like I've done this in languages like Java, where you have like a library that can persist any object to disk or to a database.
Yeah.
Then you run into the issue that as the code evolves, like the data types change, and then you end up with a version mismatch, and then like it's very difficult to get like old versions of stuff like out of storage.
Yeah.
But Unison doesn't have this problem because you can, the storage knows what type the object is, and so the hash of the type is available, and you can load that type, and so you'll always have an object of the type that has that hash, and you can recover the code for that type as well.
Okay, so even if you update the definition of the type, you can still deserialize the old types because they're kind of stored in Git ishness.
Right.
But
Stored in
then,
a sort of Merkle tree.
yeah. But then you've got the problem that your new code that you've updated expects the new hash of the data type.
Yeah. But then you'll just get an ordinary type error. And so all you have to do is basically convert the data that you've restored to the new type, and then you can store it again or do whatever. But it's all like still very much in your language, and you get the benefit of like normal things like type errors rather than like a runtime error that says like, oh, version mismatch.
Right, yeah. So you're pushing the kind of data migration problem to compile time.
Yes, basically.
That's okay. I like that because that kind of error is gonna come up and you have to deal with it anyway. But so you might as well find out sooner and with better error messages.
Right.
And
I
then
mean, you can migrate things programmatically. Obviously, you can write a program that says like, grab all this stuff and like convert it to the new version and serialize it again. You can do all the sort of normal things that you would otherwise do.
You'll end up writing functions which take user dot hash one and return to user dot hash two, that kind of thing.
Right. Yeah, that kind of thing.
And you can do that at compile time, and it will check it for you, and then just work.
Right.
That's an interesting promise for long-running computation, long-running services. So I best ask you this question. What state is Unison in? Is it alpha, beta, research, production?
I would say sort of late beta stage at this point.
Okay.
So that, I wouldn't say anyone is using Unison for like mission critical stuff in production at this moment. And you probably shouldn't. But,
right.
it's already a pretty capable language and has good library support already. And constantly new libraries being developed, as an active and friendly community, and there are all these things that are sort of converging this year, which is, we're getting Unison Cloud is coming out of beta. It's in sort of a private beta at the moment.
Okay.
So you have to like get on a wait list and stuff. But so we're bringing it out of beta this year. We're adding this storage layer, and Unison is also getting native compilation, like very soon. So you will be able to, run your code in the cloud very fast.
Okay. What's the current state of it?
So currently it is an interpreted language. So it's a bytecode interpreter.
Okay.
So it sort of compiles to a Unison bytecode, and then there's an interpreter written in Haskell that interprets that bytecode. And so we have a just-in-time compiler that's being developed sort of by the community and by Unison Computing, and that's all being developed in the open. And so it compiles the scheme now, and scheme compiles to very fast machine code.
Like, what's the other language that's Idris? Doesn't that use scheme to compile as its compilation?
Yes, I believe so. I believe Idris compiles to Ches scheme.
Yeah. I wonder what it is about scheme that makes it a nice compilation target.
I don't know. I mean, it's very comprehensible for one thing. It's it's got good performance. Like the compiler produces really good machine code, and we found that the code that's generated by the new just-in-time compiler is like between 400 and 700 times faster. So that's pretty good.
That's cool. And that's coming out this year?
Yeah, hopefully.
Okay. So there are a couple of... So we've talked about like this Git-like thing. I keep coming back to Git as my reference point for hash it and ship it.
Sure.
The other thing, which you've touched on a bit, we should go deeper in, is abilities. We had Louis Pilfold, the author of Gleam, on a few weeks ago, and he said he really wanted to bring effects, managed effects, to the language, but couldn't find a good way to do it. Have you found a good way to do it? What are managed effects for the listeners, and have you found a good way to make it usable?
Yeah. Well, so I don't know exactly what he means by managed effect, but I imagine that he means that the effects are tracked in the type. Is it a type language?
Yeah. Okay. I think he's
Perfect.
going in the Haskell typed side effects direction.
Okay.
Plus.
All right. Perfect. But yeah, so there are a number of different ways that you can do this, like manage effects in the type system. And so the way that Haskell has gone is to do this with monads. So basically, you just have a data type that's like parameterized, and the data type, represents like what kind of effects you can do. Like for instance, there's an IO. Famously, there's an IO data type.
Yeah.
So instead of just having a string, like you read a line from the console and you don't get a string, you get an IO string.
Yeah.
And so you get this data type called IO, which has a parameter which is string. So it's an IO sort of containing a string eventually. And that's a perfectly cromulent way of managing effects in the language. But it has certain drawbacks. For one thing, monads are they have a syntactic overhead in the language. So programs that are pure, that don't use any effects, they are syntactically different from programs that do use monads. And so you have these sort of two programming modes.
One of the first things you have to learn when you're learning Haskell is how to flip between those two modes.
Yeah. And then composing monads is, a sort of an evergreen topic.
Yeah.
So one of the things that people do is like, monad transformers. So you get you want to compose monads F and G. And so you need an FT monad transformer, which is parameterized by another monad G, and that combines them into this sort of composite monad where you want to do like, state and IO, for instance.
Yeah.
And so then you get this like state T of IO or whatever.
Yeah, you can
And
end up with like a program that has the side effect of accessing the database and doing logging is different to a program that has a side effect of doing logging and accessing a database.
yeah, that's
When
true.
logically, they should just have those two side effects.
Yes. So what we're doing is a little bit different. So we're taking the approach of algebraic effects. So we're calling these abilities, which is a term that we got from a paper called Doobie Doobie Doo, which is
Which is the
kind of
best title
awesome.
for a paper ever.
It's about a language called Frank, which is by Conor McBride, I believe.
Yeah,
But
I've seen Connor in action. He's a great thinker.
Awesome. Yeah. But yeah, so we got these ideas from there. And so algebraic effects are a little bit different in that you are able to combine effects sort of side by side. So instead of pressing them together using like a transformer, you have this just sort of set of abilities on your functions. So a function will be, it will require the abilities to do IO and state, for instance, and that's just like basically a set on the function arrow. And so combining these things is sort of trivial. If you invoke an IO thing, that gets added to the set. If you invoke a thing that accesses the database, you get that added to the set.
So when you're looking at the type signature, you see the sum total of all the effects that particular function has demanded in order to run.
That's right. Yeah.
And then presumably you write some code that dispatches each of those effects. So you see in your set, it says, I need logging. So you wrap that function call in with standard out logging.
Right, exactly.
And that takes logging out of the set. And eventually you get down to just a computation.
Yeah, that's exactly how it works.
Right.
And you can write, custom handlers for these things. Unison has a keyword called a handle, where you can supply a handler for any effect. And you basically just pattern match on the constructors of the data type that represents the ability. And also importantly, I think it doesn't have any syntactic overhead, or it has very minimal syntactic overhead. So a program that uses abilities looks a lot like an imperative program that doesn't use abilities. So there's no sort of monadic syntax involved.
We're not switching between do and bind syntax and regular pure function syntax.
Right. So you're always just writing sort of like a block. And so, you can just like write basically like a let block, and you can do effects there, and the whole block will take on the type of having or requiring those abilities.
That sounds a lot like the upside of Haskell. Tracked effects tracked in the type system, I think, is a really good idea. Mm-hmm. But it's hard to teach, and it's a bit of a learning curve. And it sounds like you may have solved that second problem, if you're to be believed.
I don't know if we've solved it, but I think it makes it a little bit easier to think about, at least for people who are, not versed in monads. You can still have monads in Unison, and you can have monad transformers and all of that stuff. Like that's perfectly possible. But as you know, it's not directly encouraged by like the standard library and things like that. Another thing is that there are, of course, downsides to this. So one of the downsides is that algebraic effects, at least in the form that they exist in Unison currently, are not as expressive as monads and monad transformers. And so you can't necessarily combine things in ways that you would otherwise do in Haskell.
Can you give me an example?
Can I give you an example? Like, so for example, in Haskell, you might be able to do sort of like a higher order effect where you might abstract over monads that have a particular capability. So you know, what's an example of this? Like there's something like monad state, for instance. So that's like a class that represents all the monads that could possibly be interpreted to, to track some state.
Yeah.
And so that's very expressive to be able to like abstract over all effect types that track state. But Unison's type system, Unison's ability system, doesn't allow you to talk about effects that like abstract over the capabilities of other effects at this moment. But that may come later.
Okay. I think that's probably, for the majority of programmers, this is already astronauty enough for that to be okay.
Yeah, I mean, it's a trade-off, for a lot of programmers, seeing a library that is very abstract, while using it might be pretty straightforward. Like once you get into it, like the compiler will take care of like mapping your concrete data types to their abstract types. But seeing a library that is very abstract, you may struggle to understand like how you're supposed to actually use it.
Yeah. So. Yeah, that all depends on like compiler support. Like there are functions in Haskell that are terribly useful, but like have so many type variables I can't keep track.
Right.
And the more type variables you have, the worse the error messages get.
That is also true.
Have you done anything to solve that problem?
Well, one of the ways we solve that problem is the, you're encouraged to write things in a very direct style. And so, you don't end up necessarily with these sort of type astronauty things. I can think of, a couple of libraries for Haskell, for instance, where people really struggle with error messages. And one of them is like Lens, where, it's super useful. I love the Lens library. And I use it all the time. But often error messages are really abstract, and you have to be sort of well-versed in how to use Lens in order to understand it.
Yeah.
And another one is Servant, which allows you to, basically describe an HTTP server as a type. And so you get this sort of like typed communication over HTTP, which is super awesome. And it basically just like generates all of the boilerplate for you. But the error messages it gives you are just like, it might be 20 pages long or something if you, get, like one type variable wrong. And it can be really difficult to decipher a type that describes an entire HTTP server. Yeah. And so we're taking a lot of cues from languages like Python, for instance. Like the culture in Python, in the Python community generally, is that you write libraries that work in the obvious way, and people, you sit down with a Python library and you can sort of generally you can kind of assume that it's going to be written in a kind of obvious way, that how you're supposed to use this library is going to be straightforward, and it's going to write it in a very direct style.
That's easier said than done, though. I mean, you've got to kind of agree on what counts as obvious.
Yeah, that's true.
So perhaps we should say who's your target audience for Unison? Are you expecting Haskell programmers to switch to it eventually, or is it Python programmers? Who's going to be adopting Unison if you get your dream world?
Well, in the dream world, it's basically everyone who wants to develop distributed systems, which is really everybody, because there aren't very many systems these days that aren't distributed. Even things like, systems that have a front end and a back end, the communication between the browser and your back end, if you're writing like a web application, that's a distributed system. And one of the things that we hope to develop in the future is, a JavaScript compiler for Unison. And so you should be able to write a distributed system that runs in your browser and deploys itself to the cloud.
Will we be getting a future in which the browser like checks out the hashes of the functions that have changed since the last time you checked the website?
Yeah, that would be amazing.
Oh. Oh, that reminds me of something I also remember you saying in your talk way back when, which I'll let you explain it. Perfect compilation, perfect incremental compilation.
Oh, yes.
That's a big one.
Yeah, so perfect incremental compilation. So in Unison, your code base is sort of always live. So it lives in a database and it's always compiled. So let me contrast that with, so let's do the genus and differentia thing. So
Okay.
contrasting that with the way things work in most programming languages, like let's take Haskell, for instance.
Okay.
So in Haskell, you write a bunch of text files. You proceed to mutate those text files, and then you run the compiler, and the compiler generates the code. And then if you've done something wrong, you get a long list of error messages, and you got to go mutate the text file some more, and then run the compiler. And then whenever you change something, you got to like run the compiler and like build everything.
Yeah.
Okay. So the way that Unison works is that whenever you write like a definition or a type or something, it gets compiled basically immediately. You submit it to the Unison codebase manager, and you can add it to your codebase right there and then, and it lives there in a compiled state. And then when you write some more code, it compiles that code, and then you can add that to your codebase. And so it's very sort of incremental, and your codebase is never in a state where it's like broken. Like you can never, mutate your code base in such a way that it is that it doesn't compile. Right.
Right. Okay. And you've also got like you've got if you've got like a large old code base where the majority of code there you don't actually touch.
Yeah.
That never needs recompiling.
That's right.
Yeah. What if you get a new employee come along and let's exaggerate and say we've got like Google or Facebook size monorepo, and they want to check that out and start working? Do they get everyone else's pre-compiled shared code base for free?
Yes, they do. Yep. So the way that the Unison Codebase Manager works is that so everything is stored in its sort of compiled state, and then you can push that to other locations, and the one that we provide is called Unison Share. So it's sort of like our version of GitHub in a sense, and so you push your code to share. And then the other developers that you're working with will pull that. And what they're pulling isn't the text of the program. They're pulling the compiled version down. And then they can use the Codebase Manager to view the source code or edit the source code. But the source code is not stored anywhere.
Okay, so how does that work for like if you and I have two functionally identical functions, but I've put comments in mine?
Okay, so that really depends on how you've added comments in it. So there's one kind of comment that's completely ignored. So then it just gets thrown away when you like compile your function, and if you delete the source code, it's gone. The comment is gone, and it'll never come back. It's sort of like a note to self. Another way you can write comments is you basically just put strings in line in the program, and you can, there's a little function called ignore, which will allow, just tells the program to ignore this. And that will change the hash of the program. And so, if you have identical functions that have like different comments, they do get treated as different functions. So we've toyed with the idea of adding a third kind of comment, which is sort of like a comment that lives in the compiled form but doesn't contribute to the hash. But that has the downside that if you ever want to change the comment, you would have to like basically delete that hash from your code base and add it back with the updated comment.
That's nasty.
Yeah.
Hash the metadata separately.
Yeah, that's another thing we could do, is to basically put and Unison, the code base format has this facility for metadata, now. We include things like who wrote this and what's the license,
Okay.
and stuff like that. So every definition has, some metadata hanging on it, like author and license, and maybe whether or not it's a test, where's the documentation, things like that.
Could you theoretically then say, I want to make sure that in production I'm not running any proprietary code?
Yes, you can. And you can computationally do that. You can basically write a program that takes a unison expression and, at
Checks
least
the metadata.
theoretically, you could
Walks
check
the
the
tree.
license,
Yeah.
walk the tree, and ask it, does
Or I
this
can make
use
sure,
any GPL?
Yeah. Or can I make sure that none of my test code makes it into production?
Yeah.
Yeah, that's pretty cool. Okay, one more thing on that then. So you're saying I write a function, it gets hashed, and the compiled version gets shipped over to the central repository.
Mhm.
Someone else checks it out. They can't get my syntactic sugar, so there must be some official code formatting for Unison?
Yeah. So Unison will format the source code. So, there's it currently has one surface syntax, but theoretically there could be many. We've toyed with the idea of having like a Lisp syntax for Unison.
Oh, and I could write mine in Lisp, and my colleagues would never know.
Your colleagues would just they might see like the Haskell like syntax that it currently has. But yeah, the source code is thrown away. So you're never sort of like faffing about with formatting or whatever. You just like write your code, submit it, and you can just trust that it'll look nice when it gets rendered. Or, if it doesn't look nice, at least it will look the way that Unison code is supposed to look.
Right, yeah. You have to agree with the one true way of formatting code, but I'm kind of pro that.
Yeah, I like that too. I don't like to have to think about, formatting my code. That's just like not part of the job.
Yeah. I'd rather the entire team agreed on one code formatting, and we all got it for free, right?
Yeah.
Rather than debating and hand crafting to match the blessed guide.
Right.
Yeah.
I mean, we have, Unison is mostly written in Haskell. And so we have in our Haskell code base, there's this sort of blessed format, which is generated by Ormolu. And so, we'll have these like commit triggers and whatever, so that whenever you submit new Haskell code, it all gets formatted in the approved way and whatever.
Yeah.
But even that can be contentious. Like, maybe you have different versions of the formatter, or, maybe you don't like the way this is, and so you kind of want to tweak it. And so you may have to like form a committee about like, do we want to tweak this parameter here? So even that like leads to bike shedding. But in Unison, that is just like completely out the window. There is no tweaking the formatting at all. You get what the code base manager prints out, and that's it.
But in theory, you could have your preferred formatting that no one ever needed to worry about.
That's true. In theory, you could do that.
Because I've worked on teams where every single person just wanted the unified formatting except one guy who would absolutely refuse.
That's actually a good point. We could introduce facilities so that you could tweak the formatting for like just your instance of the codebase manager. So locally, you're developing in beautiful Unison code that is exactly the way you want it. But then once you submit it to the codebase, everybody else sees it the way they want it. But then you see their code the way you want it as well.
Yeah. Philosophically, this is it seems simple, but very different, that we're still dealing with text files, but we're not really. Text files are just a projection of what we're really dealing with.
Yeah, that's right. I think that code as text is really just a user interface onto like what you're actually doing. It's a really good user interface. Like, it's very expressive, highly flexible. We've toyed with things like structured editors, and so where you're like directly editing the tree and like you can't get compile errors and stuff like that. And I think that ideally that would be awesome, But the user experience of it, I've never found it to be as good as just writing text.
Yeah, I tend to agree. So, I mean, that sounds like something maybe for the next version or a few versions down the line.
Yeah, a few versions down the line, maybe we'll have a structured editor.
Yeah.
And custom formatters.
Yeah, I can believe. But where are we today? If I go and check out Unison, what kind of experience can I expect to have? What kind of libraries am I going to wish were there but aren't? What can I do with it?
That's a good question. What kind of libraries would you wish there were but aren't? Well, so when you install Unison, if you have like brew, you just say like brew install Unison lang, or Unison language, and you can go to the website and like download the binary if you're on like Linux or whatever. And it's really straightforward setup. There's one executable. You run the executable, it's called UCM. You just run the executable, and it's listening to changes to .u files in the current directory. And so then you open your favorite text editor, you open a buffer named .u, like something.u, and you just edit. You can write Unison code directly in there, and whenever you save it, UCM will pick that up and type check it and give you some feedback about it. And then you can interact with the UCM to like add it to your code base or ship it to Unison Share or stuff like that, or run it. So yeah, it's a very minimal setup. Like there's not a lot of like configuration or installation that needs to happen in order to get going, and you can really just like start writing code right away. There's nothing to like set up.
I tell you a way that this would instantly interest me, right? So I can imagine going to a hackathon with Unison. Yeah. I run this Unison code manager. What I'd like to do quickly and easily is connect it to my teammates' laptops in such that if I write a new function, they can instantly pull it in. Is that something I will need Unison Share for, or can we just do like a local GitHub?
You can use Git in order to like push code around. It does support that, but it supports it as binary files. So you push your code base as a binary file to, like a shared Git repository, and they can pull it from there. Yeah. But the nice way of doing things is just to use Unison Share, because you're not pushing these binary blobs around really.
Okay. So another thing we had recently on the podcast was we were talking about Advent of Code. As like a coding competition for different programming puzzles that goes on once a year. I saw you had a Unison challenge around Advent of Code.
Yeah, we did.
Where people participate. That must have turned up a few like holes in the standard library, that kind of thing. Did it?
Oh, absolutely. Yeah, that was fantastic. There's seeing people, solving these sort of simple programming puzzles. It turned up a lot of useful functions that weren't in the standard library, maybe whole libraries that didn't exist but should have. But I actually would love to know the answer to this question. Like when somebody sits down, with Unison and like wants to get started, like what libraries are they finding aren't there? Because I don't know the answer to that, and I would love to know, because I want to write those libraries that people want.
Yeah.
And like farm them out to the community. Like the community is hungry to write useful libraries.
Cool. I'll give you three off the top of my head, because these are the first three I always look for in any language. Can I do a web server, a web socket, and connect to, let's say, Postgres?
You can. So the first one, yes. So there's a web server library. There's also another library that I'm currently working on that creates a sort of very ergonomic API on top of that low-level web server. There is there's not currently a WebSockets library.
Okay.
But that's a good one. We could definitely do that. And you can connect to Postgres. There is a little library that allows you to connect to the simple Postgres protocol. But currently underway is development of a library that allows you to, do connect to use the more advanced Postgres protocol, do things like prepared statements and things like that.
And is there like an interop? Have you got any way of like creating a new library quickly by reusing a Java C library, something like that?
No, there isn't anything like that.
Okay,
There's
so it's got to
currently
be
not
written
any.
in pure.
Yeah, it's got to
Unison.
be written in pure Unison, or it has to be added to the Unison runtime, like through Haskell. That's currently the way things are. But that won't be that way forever. I envision a future where you'll be able to make calls into foreign functions, using the scheme interface.
Yeah. And speaking of the future, perhaps to end on, do you think you've got the big idea you seem to have here? I mean, you've got a few big ideas for mainstream programming, but the big one is this idea of hashing code and storing and sharing hashed code. Do you think that will start to percolate into other languages? And is that something you're trying to do?
Yeah, I think so. I think we're kind of already seeing that a little bit in various places. I mean, there's things like Nix, for instance, that is very much this idea that everything is hashed, but the granularity is different, obviously. There is I saw some work underway last year with Haskell, where they can do like term equivalents up to hash. So you can, so basically inside the compiler you can decide whether two things are the same, like based on the hash. But that's not yet like communicating between machines or anything like that. But yeah, I see this idea of hashing come up like all over the place, and like even like languages that are based on like, I don't know, blockchain or whatever. I mean, the basic idea is that you have some like eternal address for an object, and then you can like always refer to that, that address on the blockchain or whatever.
Yeah. They're encoding code on a hash, and like you send money to a hash, which turns out to be an executable contract, that kind of thing.
Yeah, basically.
Yeah.
And then there are like distributed hash tables, like what's it called, HSF FS. I forget what it's called, but there's a number of implementations of like distributed hash tables where you can like store data like in the ether, basically by hash.
This big content addressable storage super network.
Right.
Oh. So what we're saying is this idea is already percolating into the world, and a great place to discover it would be Unison.
Yeah, I think it's sort of an idea whose time has come, and it has a lot of benefits. Like, and it comes with a lot of implications that changes the way things are done. Like things like builds and like dependency management and internode communication.
Yeah.
Like basically everything changes when you start to refer to things by by a deterministic name rather than some invented name.
Yeah, and some invented and commonly reused name. Like function name tends to apply to all the versions of that function we've ever written, right?
Yeah, and you'll have a data type called list in a standard library or whatever, and like, well, do you mean list version 1? Do you mean list version 2? Like, who knows?
Yeah.
And like, you will have different dependencies that might make different assumptions about what a particular name refers to, and if they don't agree, then you'll get like in the best case, you'll get a dependency conflict at compile time or at build time. In the worst case, you'll get a runtime error, and so we avoid that.
All based on this problem we know exists, but we kind of hand wave over because we've never had a good way of solving it.
Right. I think so.
Oh. You might be a good way of getting to the next level of programming. I certainly hope so.
Yeah. I mean, I definitely want to encourage people to just like come to, the Unison Slack, come to the Unison website, download Unison, install it, play with it, and let us know like what's missing, what could be better. Or let us know what's great, what's cool. Like we
That'd be
really
nice
want to
too
know.
on the internet, right?
Yeah.
Yeah. Cool. So unison-lang.org, is it?
Yes, that's right.
We'll link to it in the show notes, but yeah. For now, I think we should leave people to go and check it out. But for now, Rúnar, thank you very much for joining us.
Thank you so much, Chris.
Cheers. Thank you, Rúnar. It's my ambition for this podcast that we'll be always looking to where we hope our industry will be in 5 or 10 years. And if we just manage to get 1 or 2 of Unison's ideas into the mainstream, I think we'd be in such a better place. I hope Unison does it. I hope someone does it. Even the approach to incremental compilation would change our working lives, change the speed at which we build and deploy. I worked at a place once where their CI server was so log-jammed that you would wait overnight to see if a branch would build. I don't think that's so uncommon. Incremental compilation would have made that as simple as compiling a few functions. I really hope it goes mainstream. I look to the future, as ever, with optimism. But that's all for now until we reach the glorious future of next week's episode. Take a look in the show notes for links to Unison and how to get started. I'll put in a link to that wonderfully titled research paper, Doobie Doobie Doo. Check out the like and subscribe and share buttons if you'd like to show your appreciation. And I think that's all. Until next time, I've been your host, Chris Jenkins. This has been Developer Voices with Rúnar Bjarnason. Thanks for listening.